Hey, I'm Taylor Dirks. Thanks for checking us out. I wanted to get a video out that kind of outlines our 10-step process on how we build fertilizer recommendations. There's a lot of ways, a lot of different methods to build a fertilizer recommendation, and we definitely did not invent any new theories or methods or machinery. But rather, we are proud of the fact that with the conventional process, we've taken a step back and we've evaluated every part of how it's conventionally done and wondered how could we do better. And so what we've put together is what we believe to be kind of the best of the ways that we could find to do every step of that process. And then at the same time, we're still learning. Every year we may change part of the process, but we have enough to build a foundation that we can build on. And so our process is built to boost the efficiency of your fertilizer investment year after year. That initial investment pays year after year because that plan can be applied year after year. It can be watched to see if it's working. It can be adapted. It can be changed. But if you're not testing, you're just taking a guess. And so this is the foundation that we think we can build on. And that foundation is, for us, we call it a SWOT map. And that SWOT map starts by building an EC map. So when we map electrical conductivity in a field, we're using this sensor on the back of a side-by-side. And this sensor, we call it the EC sensor. It sends electrical current into the soil and measures how easily it flows between 2 points, or it measures how much it's getting back from the soil. And so the heavier the soil and the better water, the higher water holding capacity that soil has, the higher the reading we get. And it does a very good job of separating the heavy soils from the light soils in a field. So it separates the silt and the sand away from the heavy clays. So really it's very similar to mapping out the soil types that we have in a field. And so on top of that electrical conductivity data, we use elevation data from the source LIDAR. And we use elevation data to separate different types of high or low EC data. One instance that we run into a lot is that we will have two totally different areas with a high EC reading, and one of them will be a heavy black soil in a low spot or the low end of the field along maybe a creek or whatever. And then we will have another high EC reading on top of the hill at the top end of the field where topsoil has mostly eroded away and it's left a heavy yellow clay. And so obviously we want to manage that heavy yellow clay on top of the knob much different than that fertile soil, the creek bank gumbo or the heavy black soil. And so we can use that elevation to separate those two types of heavy soil. It's another layer that can add definition to the properties that we measure in the field. We also can model water flow, and it has some impact on that field, as well as topography. And topography is different from elevation in the way that a topography map shows a higher reading where the percent slope is higher. And so it's really a map that shows or defines slope. And so some mid zones between 1 and 10 are oftentimes zones with slope. So they can somewhat influence the map as well. And so every SWOT map, once this data has been combined into a SWOT map, it is divided into 10 zones. Each field is divided into 10 zones for consistent detail. It provides us with a lot of definition, and yet it still gives us a standard way to divide a field's variability. So zone 1 and zone 10, zone 1 is always the highest, likely the highest and driest part of the field. Zone 10 is usually the lowest and wettest part of the field. And the color scale always remains the same. And so over time you get used to looking at a SWOT map and knowing what zones you're looking at and comparing zones, zones 1 and 2 from this field to zones 1 and 2 of this field. It's a very standardized way of thinking about these zones in a field. From there, we will soil sample each zone. Now that we have divided all the soil types and situations into their own separate fields, we go and pull multiple sample points from each one of those zones. And then after those samples have been run in a lab, the sample results from that zone are all averaged together. And we like the average together approach for multiple reasons. But one is if the sample results come back from one zone and they are all over the board, then we're not very confident in our zones. We might need to go reevaluate how we built those zones, or maybe we missed something when we were out there ground truthing that map. Or maybe all of them, they come back and all of them are very consistent, but one of them is just through the roof in every aspect. Well, we can kick that sample out and it doesn't have to be throwing anything off. Maybe that sample was pulled on a cow pie or whatever, but somehow that particular sample is not consistent with the rest of them, and it gives us other samples to compare this sample to. It also kind of just builds on composite sampling. There are some benefits to composite sampling, and really one zone is just its own little field, and that we are composite sampling. From there, we compile the data, and like I said, we average those samples together, and they all find themselves in one line on our report. And we have the basic soil test data on the one main report that comes out of this process, and along with that, it will show right underneath those numbers what percent it changed from the last time we sampled, and we can see whether we're gaining or losing ground or what exactly happened. And so it's another level of insight that is not common, is to easily see that percent change. From there, we need to build a yield goal for every individual zone. Every zone has different properties and responds differently and has a history of doing what it does. And so we can go back and look at that history using combine yield data. We can look at satellite imagery, and we can sort out the crop that we're getting ready to grow. We can see what it's been doing. We can look at the soil test data and see, okay, so we're working on this and it's been yielding this, but if we fix this, a good yield goal for this, if we want to push it, is this number. So every zone gets its own yield goal, and that very much affects, from a removal standpoint, when building the fertilizer plan, it affects that. So for instance, if we're used to having a 180 bushel yield goal for corn on this field, well, now we can still have an average of 180 bushel yield goal, but some of those zones always yield more, and so we know what these zones are going to have to make and what this zone is going to have to make, and we can fertilize accordingly. From there, now that we have the yield goals, we have all this data collected and easy to visualize, we can evaluate each one of these zones by themselves and find places to reduce waste, find those places that things that can be read on a soil test, or at least at a macro level, are not what's holding back yield in this area, like potentially drainage issues, compaction issues, whatever it may be, and then areas that have been likely been removing a lot more than they have been getting, and the one big thing that's restricting them is severely low phosphorus levels, for instance. And that seems to be the only thing at this point holding it back. We can find those opportunities, and every field is different, and every field has a different opportunity to save or quickly return on investment. But every field has opportunity, and we just have to find those. So when we find those opportunities, then we can make the plan. And we make a unique fertility plan for every zone by itself, and then they're compiled into this report that lists out the products and rates recommended to capitalize on the opportunities that we found. And along with that on the report, it gives us the weighted averages across the field of what it's going to cost, and some zones are going to get a lot more money spent on them than other zones. And the beauty of it is that we can reallocate money from the zones that won't return to the ones that will return. And so it's kind of killing two birds with one stone. It's cutting waste and reinvesting at the same time. And then we have a field summary on the report, and it puts into words the opportunities that we found and what we think we can do about that to capitalize on them. Every report has our score system that we've come up, and it's basically based on how much of the estimated gross profit, based on the yield goal that we've set for the field and current commodity prices, and it puts the total fertilizer cost against that to give us a score 1 through 10. And so 10 is a very good investment and is a field with little investment to how much we plan to or think we can get back, and a score of 1 would be the opposite of that. And so all of that goes together into our one easy to read report, and everything fits on one page, at least at a macro level. There are things that we test for and look at that can't be fit on the report, but we thought it was very important to get the bulk of it on one report and make it easy to digest. No more stacks of papers of surfaces, a single surface for every single nutrient. Say you have 15 to 18 pages per field. It gets very taxing very quickly to go through very many acres like that. So we fit the bulk of it onto a one-page report that we've tried to design very cleanly. It lists out the goals that we have, percent change from last year on the soil tests. It lays out the zone map, and those zones never change, and so over time you remember what those zones look like, and then the products and product rates and overall costs, along with that score that can be compared to other reports, and you can compare field to field how we're doing on our investment ratio. And so this report can also be edited in real time during discussion with the grower. Let's say we missed something, or he has insight, because the grower always knows the field better than we do. He has insight that, hey, maybe this zone, that's not a reasonable yield goal. We can change that on the fly. The rates update on the fly, and there is no more writing down notes on a paper pad and updating things later and then sending another report and asking for an okay on that report. And so it's just a very easy process to edit when we present this to the grower. And then once those rates are locked in, we can go ahead and make the spreader files and the final maps and send them to whoever is going to be performing the application. So thank you for watching. That is a quick rundown of our process that we call our crop fertility system. And if you have any questions or want to demo this system on your farm, we will do up to 100 acres at no cost for you to see it work on your farm. Give me a call at 660-679-1046 or message us here on Facebook. Thanks for watching.